Hi guys, so today we'll be solving this problem called combination sum 4. Let's read it. Given an array of distinct integers, nums, and a target integer target, return the number of possible combinations that add up to target. The answer is guaranteed to fit in a 32-bit integer. For example, nums is given as 1, 2, 3 and target is given as 4. So we have to return the number of combinations which are possible to get us the target as 4. So here it is 7. Let's see how we get 7. So the possible combination ways are 1, 1, 1, 1, which makes it 4, 1, 1, 2, 1, 2, 1, 2, 1, 1, 1, 3, 3, 1, and 2, 2. Note that different sequences are counted as different combinations. Correct. So even though if we get like a type of combination, we have to also uh, count the number of different sequences which are possible in that combination. So for example, 1, 2, 1 can also be written as 1, 1, 2 or 2, 1, 1. So we need to count that. And for example, nums is given as 9 and target is 3. So we return 0 because we don't see any matching target here. So what if negative numbers are allowed in the given array? How does it change the problem? What limitation we need to add to the question to allow negative numbers? All right. So first of all, when I see this problem, I see that there is a combination and there is a choice. We have choices to select that particular element or not. So whenever we have choices, we know that this is a mental model that you need to fit in your mind, that you have to solve the problem by dynamic programming or maybe by recursion. You have those two choices that whenever you see choices in the problem, you know that okay, here I think I can try dynamic programming. So I'll be solving this problem by dynamic programming, but a, a memoized version of it, so that it is more intuitive, and I'll be showing how the DP would be filling. All right, so let's just dive into it and I'll show you how it will work. All right, so okay first let me just hit the base condition that if nums of size is equal to 0, we return 0. So we know that if the nums array is 0, it doesn't have any length in it, so we return 0. And then let me just define the DP here. Vector of int DP target plus 1, and I initialize it to -1. So I take a DP, I know that what I'm going to do, what is changing here is the results changing. Because every time we select an element, we know that the results are changing. Therefore, I initialize the DP with target plus 1. And now, let me just let me just take an example. For example, nums is 1, 2, 3. All right, nums is 1, 2, and 3. And the target which has been given to us is 4. So let me just write it here. Now, and nums, I make the DP, I initialize it. So your target plus 1, which is 5, and I initialize it to -1, -1, -1, -1, and -1. So let me just write the index as well so that you understand it properly. 0, 1, okay, 2, 3, and 4. There we go. So first we know that we have initialized the DP with -1, and we would be passing this to a function, right? So let me just write down that for you. So we say that this function called solve, where I pass nums, target, and DP, it will give us the answer. We don't need to worry about anything. This function will directly give us the answer, and we have to state return it. Now, in that function, we would be returning the DP, right? So we need to understand how that DP would be filled in that function. So since I've initialized the DP with -1, -1 is the initial value, and we have to find the number of combinations, or the number of the combinations only number of combinations which are possible for a particular target. So for 0, it would be, whatever we get here. Here we don't have anything. So therefore, 0 would be initialized as -1. Then we have 1, and we see that we have 1. All right, we have 1 in the nums array. So we know that there is one way to get nums dp result as 1 from the nums array. All right. Now when we see 2, 2 would be having we can get 2 by 2 combinations, which is either by getting 1 1, which is one combination, or either by getting 2, only 2. So we have 2 combinations which are possible, therefore we store it as 2. Now when we reach 3, at 3 we know that 2 1 is one combination, 1 2 is another combination, because we need to make sure that sequences are also in our mind. Then 1 1 1, which is also a combination. Then 3 itself is a combination. So we get 4 combinations which are possible in 3. And when we do reach the final target which we need to solve for, we see the number of combinations which are possible from the states which are already pre-computed. We store it in the result, and we return it. For 4, we see what are the combination possible. So 1 1 1 1, which is one combination, 1 2 1, which is another combination, then 1 1 2, which is another combination, then there is 2 1 1, which is just a sequence of 1 1 2, right? So these are the three combinations which makes it 4. Now then we have 2 2, which makes it 5. Then we have 2 1 1, which makes it 6. Then we have 3 1, which makes it 7. Okay, sorry, 3 1 and 1 3. 2 1 1 I've already counted, so makes it 7. All right. So this would give us the answer as 7 here, and therefore we return the answer which which is the target from that solve function, and we return it similarly here. Now let me just code out the part which I explained it to you. It's quite intuitive. I think you would understand it properly, and obviously with memorization you can understand more intuitive solutions. So I name it, I've already named it for solve, and I copy nums, I copy target, and I also have TP here. All right. So we have this function called solve. This will solve the answers and get the combinations for us. So for now, first I'll create a variable result where I'll store the answers, and let me just loop through all the possible combinations for from the nums.size which we can get to hit the target. So we do result plus equal to I call the function solve. This is where memorization is working. So I pass nums, and I also pass target of nums of I. Now what we are doing is we are getting exactly what we did here. So for every result which we get, we know that there is already answer stored in a DP, and therefore we return it. And otherwise, we compute it. So we pass that as well as we pass DP. And as soon as we hit the target, we return the result. All right. Now let me just write the base conditions of how the function would hit the hit the bottom. So if dp of target is not equal to -1, then we know that we already have pre-computed this answer, and we return the dp of target. Now if target is equal to 0, so we know that we have hit the target and we've found the answer, and therefore we return 1 here. And if target goes into the negatives, so we know that this is not where you need to be, and you return 0. And similarly, as and when we hit the bottom, we return 1, and the results get increasing and increasing and increasing. And when we get that particular target for particular target which we are searching for, in that recursion we store it in the DP, or otherwise we've already pre-computed, we return the DP of target. So yeah, that's all we need to do in this solve function, and this solve function will give us the answer, very smoothly, and we don't need to worry about it, and we return it here, return the solve function here. So let's run the code to see if we don't have any bugs. Yeah, that works. Yeah, that is accepted. So I hope you guys understood the problem today. It was an amazing problem to understand as well as to visualize, and it was quite intuitive to understand it. So do solve it. Thank you.